Right, so hey guys, it's pretty amazing to see how much brain power there is in this room. I'm excited for the end of the 6 weeks and what you guys come up with. A little bit about me. I am the founder of Block.io Inc., which makes the easiest APIs for Bitcoin on the planet. And that's just not just me saying it. Once you look at it, you'll understand why. And before Block.io, I used to run companies that built Facebook applications back in 2007, 2010. Some really popular applications, very large scale, second behind Farmville, a lot of traffic. Scaling those applications was a big challenge, and I see that challenge in Bitcoin as well, especially as traffic keeps ramping up every single month. So in 2010, I got rid of those startups, sold them, and focused on my PhD in computer networks, online social networks, and now here I am in Bitcoin. And so that's basically me. This course, we will try to take you from the ground up. We don't expect you to know anything except be able to reason logically, which I think is a reasonable assumption. If you're able to reason logically, you can think like a computer. That's the basic idea. Languages today, for example, JavaScript, Python, Ruby, all of these languages are not what our ancestors, I guess, coded in. They're not C, they're not C++, no curly brackets and all that. So they're not as confusing as they used to be. They're pretty close to human language, and it's going to be, I think it's going to be super easy for you to get started. Just keep in mind that computers work with if, then, else. That's the basic idea. They don't have emotions, they don't do stuff on their own, and you'll be fine. And it sounds kind of funny, but that's the way I think about it as well. Sometimes you get angry and think they're messing with you, but they're not. All right, so what is the blockchain? Before we talk about the blockchain, we got to understand what Bitcoin is, because Bitcoin is something that uses the blockchain, right? The reason we're here is because we've heard about the blockchain and what Bitcoin is. So we've all heard things like, oh, it's the most revolutionary technology since the internet, and the founder of Netscape, the first popular browser, will be like, Bitcoin today is in the same phase internet was in 1994. So there's some big claims. So what do they have to back it up with? Are they just sound bites to get them in the newspaper? What is Bitcoin? We know we can transfer money through it, but it's not really money. It's a representation of what we call money, which is paper money we hold in our hands, in our wallets, and wherever. So, as a general framework, what can Bitcoin do? Think about it this way. Anything that holds value in the world, anything quantifiable, you can use Bitcoin to transact. What I mean by that is something I'll explain later on. So don't think about financial transactions. Think about value transfer, right? We're sitting in the US, our friends are sitting in Australia. If we go through a bank, it's going to take about 24 hours to 48 hours for our money to go through them. They're going to charge us a lot. By a lot, I mean even $25 is a lot of fees to pay for money being transferred from one country to another, because you live in a digital age. Why do you need to have 15 people look over your transactions every single time you do them? That's just time wasted. You can replace entire rooms of accountants with a single Bitcoin API. So instant value transfers, and the cool part is you don't need a custodian to do the work for you. You can do it yourself. You can have the network do it for you. right? If you want to think about what Bitcoin brings to the table as a general framework, think about cars. Back in the late 1800s, you had people like Henry Ford coming up with cars, and people were confused. Like, we have horse carts. Why do we need these cars? They break all the time. And what if we run into a ditch and mud and all that? So, they had a lot of doubts about it. In I think early 1901, they actually held a race where they compared horse carts versus cars to see which one is faster. Like, they actually had to go through this exercise to get comfortable with the idea that cars are actually worthwhile. And people today that say that money, what we have in our pockets is good enough for us, we don't need the network, they're missing the point. It's about automation, it's about speed. And fees and all that is something secondary to that. Okay, that's pretty cool. Bitcoin sounds, it could be pretty big, but it's super complicated to use. So are people actually adopting it? Well, yes. So if you go to GitHub, if you look at the open source repositories out there, they're popular behemoths in the payment space, PayPal, Stripe. If you look at the number of repositories that mention PayPal and Stripe and Bitcoin, you will see Bitcoin far outpaces them. And this is about a year old. This difference has gotten a lot larger. Bitcoin is twice the size of what it was at the end of 2013. So that is gaining momentum. That's cool. So developers, we love complicated stuff. So it's okay. We are adopting something complicated. It suits our nature. But is there money in it? Yes. If you come up with a good idea, if you have a good business plan, there's a lot of money flowing in the space. So, and you're in the Bay Area. As long as you have as long as you have your business plan together, you should be fine with money. So don't get scared by the prospect of not having enough funds to start a company. Just put together a pitch deck and go and get some money. It's a bubble, it'll come down, but use it while you can. Alright, so existing use cases of Bitcoin. We know it can be used for financial transactions. There are some coffee shops that we can go to and we can pay them in Bitcoin, and that's pretty cool. They'll probably let you walk away without a single confirmation of the thing, but that's for later. So you can use it for financial transactions. You can, there are payment processors out there. There are tipping bots out there. DogeTip was the one that started it. ChangeTip is the company that took the idea a little further. Payment processors, Coinbase, BitPay, these guys. What else can you use it for? Think about Bitcoin from henceforth. Think about Bitcoin as a network on which you can transfer value from one entity to another. Okay. When I log into a website, I'm actually giving away some value. I'm identifying myself. That is of value to advertisers. That is of value to other people. There is some value that I'm giving away when I log into a website. You can do that through the Bitcoin protocol. It's not exactly, you're not making a transaction on the Bitcoin protocol, but you're using the public-private key cryptography that Bitcoin very heavily relies on. And there are companies that are doing this. So there's OneName.io by two students at Princeton. And there's Keybase.io, the ex-OkCupid guys, they started it. You can also store proof of events and agreements and whatever you can quantify, or shouldn't say quantify, but you can store proof of stuff on the blockchain. We will talk about how to do that in a bit. And there's a company called BlockSign, which is a copy of DocuSign or HelloSign. So you can go in and upload a document, you can sign the document, it posts the proof of that signature on the blockchain. The idea is at any point if BlockSign goes down, 100 or 200 years later, someone can come up to the blockchain and say, hey, did Atif actually sign the lease for that car, or was he just driving that around? And the blockchain will be able to tell you because of the proof that you put in there, right? So there's proof of existence. Now all of this stuff is happening on the blockchain. As long as transactions occur on the blockchain, they're leaving some trace behind, right? So there are time patterns, there are size of the transactions between whom the transactions occur, and so on. So there's research potential in here, and there's analytics for this. You can extract things like reputations. You can extract things like, who is trying to defraud their customers, who is trying to defraud their the payees, and so on. So there's a lot of stuff you can extract from this blockchain. And there are analytics companies like Quantanalytics.co that are trying to do this for, I think, banks now. And these are just some of the use cases. There's a lot you can do with the blockchain. It's not just about finance. Right? Any questions at this point? Yes?
What shouldn't you do?
What shouldn't you do on the blockchain? Anything you can't quantify. Really broad. I love my hairless cat, right? I can't quantify that love. I love it so much. I won't be able to put that on the blockchain. That's still too generic. Anything you can't quantify, you don't want to put it in there. Because what are the two cases? The two cases are you will either underestimate its value or overestimate its value. Either way, another person is likely not to agree on that value with you. Right? So when you transact that value, you are actually giving away some real world worth to get those units of account that you transacted.
Well, you can still verify that an unquantifiable statement was made. So in that sense, unquantifiable things are still okay if they need to be verified as being stated.
This is super abstract.
Well, it's.
But no, we're going to talk about it. Yeah, we're going to talk about it in the break over some donuts because we need sugar for this. All right, so let's talk about the basics of the blockchain. We haven't talked about what the blockchain is right now. We're just talking about Bitcoin. Okay, what is Bitcoin built on? Bitcoin uses, it's not something that just sprang up all of a sudden. You go into the hospital once and your sister-in-law is there, and all of a sudden there's a 20-year-old baby just staring at you and asking you for a job. It didn't occur like that. It was a little baby. It learned from experiences of others, and then it grew. The Bitcoin network is built on technologies that came before it. Number one, cryptographic hash functions. These are the modern day cryptography workhorses. Without them, cryptography, as we know it, probably wouldn't exist. Modern cryptography, yes.
Okay.
Yeah, go ahead. As long as you don't flash.
Sure.
Okay, good. And there are some different families of cryptographic hash functions. MD5, SHA-1, SHA-2, and so on. We're going to talk about what these are in a bit. But just know that this is a crucial part of the Bitcoin protocol. Without it, the protocol falls apart. Cryptographic hash functions are also used in public key cryptography. What is public key cryptography? Has anyone over here used PGP in emails? Okay. Okay, good. So for those of you who have not used PGP, PGP was something invented by what was his name? Phil Zimmerman. Yes. Was invented by Phil Zimmerman in in early 1990. And what he was trying to do was, when I send an email on the internet, it's super easy for someone else to claim to be me, right? So when I send an email to my mom, what is the assurance that the sender is me? There is no reliable way you can tell. I can sign my name in there, but that's just letters I type. There is no handwriting analysis, nothing you can do on top of it. So how do you make sure that it is Atif that sent the email? It is Atif who is asking for money from mom. My mom would end up sending it to the prince in Nigeria. I don't know. So you need to assert an identity. You need to assert the source of the message, and that you can do through pretty good privacy, which is PGP, and that uses public key cryptography. What that is we're going to talk about public key cryptography in a bit, but just know that you are ascertaining the identity of the person through public key cryptography in PGP. Right? The third thing that we use in the Bitcoin protocol is BitTorrent. Why do we need BitTorrent? We're not downloading movies, we're not downloading Game of Thrones Season 5, Episode 1, comes out tomorrow. So why do we need BitTorrent? Well, you need BitTorrent because there is a location on your disk where you are storing all these transactions that occur on the network. Right? So think of Bitcoin, the ledger, the register, as a file, and that file needs to be shared among different nodes. Right? Otherwise, if you are not able to download that file the minute you connect to the network, how will you know what transactions are in there? How will you know that this person that is trying to send me a transaction, the money that he is spending was actually given to him at an earlier time? We're going to talk about this stuff in a bit, but you're using BitTorrent to transmit that data between the network, among the nodes in the network. It's not exactly BitTorrent, but just go with it for a bit. It's a different protocol that's a lot spammier than BitTorrent. All right, the fourth thing we use, and this is super important, is proof of work. This is a system that was invented by Adam Back in 1997. So when you write academic papers, which he did, you need to, in order to get into a good publication, you need to come up with a great use case that people can say, oh wow, this is amazing. Just like you would pitch to an investor, you would be like, okay, so this is, you won't say this is the cryptographic hash function and I'm going to give it to the shopkeepers so they can, no, you're not going to do that. What you are going to tell them is, this is a tool that I will sell to shopkeepers and they can do whatever with it. So you need to come up with a use case for every single technology that you put out. And for Hashcash, the use case he put out was, a lot of people will send spam through emails. I could send 50,000 emails within a minute, but the recipient, how does he know that this is not spam? I could be sending it to a lot of people. All of them could consider it spam. All of them don't know if it's spam or not. So what is a reliable way of doing that? A reliable way of telling whether something is spam or not is making you do some work before you send that message, so we know it's not just something you just drunk texted or something. So he did that by taking a representation of the message that was being sent through email, and then taking about a minute to come up with a cryptographically determined string, which we call a hash, and then appending that into a message. So the property of the hash was the recipient would be able to verify that this hash is valid immediately, but the sender would need to calculate that hash for about a minute or so. So any email you receive from that guy or that girl, and that hash is in there and that hash is verifiable, that means this is not spam. That is proof of work. You did some work, I can prove it, therefore this is not spam. Bitcoin uses this very heavily. And lastly, this is something new, and this is an amalgam of different technologies that came before it, is the blockchain. Okay, what is the blockchain? The blockchain is quite simply a book of accounts that is divided into transactions. What is a transaction? We're going to talk about that in a bit. Well, yeah, a transaction can actually carry instructions to send units of account from one or more entities to one or more entities, right, on the blockchain. And those entities are identified by their cryptographic representations on the Bitcoin network. Every single time you send a transaction into the network, someone needs to validate that transaction, and someone needs to lock it down so you can't spend the same coins again and again and again. Right? The problem before Bitcoin on the internet was and this is why you needed third parties, not just on the internet, but since the Medici era in the Renaissance. You needed them because as long as you have an intermediary between two people, that intermediary can come up to you and say, yeah, Atif can't spend those $5 he gave to Chris because he gave it to Chris. You can't double spend the $5. Before Bitcoin, the problem of double spending was there was no solution to it on the internet, right? Everyone with me so far? Yes. Right. So when you push a transaction into the network, someone needs to validate that transaction. Someone needs to say, yeah, the coins being spent in this transaction actually belong to Atif, and they have not been spent before. Right? And at this point in time, I'm locking it down so these cannot be spent again. Right? The way they do that is through proof of work and through something we call finding of blocks. What is a block? A block is a collection of transactions that are being validated for the first time. And whenever you find a block, we're going to talk about what finding a block means. Whenever you find a block, you have validated transactions in that block and transactions that occurred in a chain of blocks before it. Right? That's very cryptic. Let's break it down for a bit. Whenever you send transactions into the network, those transactions are processed in batches. Okay? So think of it as a bucket. I'm holding a bucket. I'm pushing transactions into it. At one point, I will be able to calculate some cryptographic hash strings that will satisfy a certain property. It'll take me some time to do this, right? And it's not just me trying to do this. There are a lot of people on the network trying to do exactly that. They're trying to validate these transactions because they get a reward at the end, right? So they're trying to do some work. If the network can reliably prove that their work is valid, they are rewarded some coins, they are rewarded the transaction fees in those transactions and so on. Now what that does for you and I is it validates a transaction and it locks the network, it secures the network. So we can actually make those transactions on it and be assured that coins will not be double spent, the coffee that I paid for has actually been paid for, and so on. That's what makes the network secure. It's proof of work. And we do that through finding of blocks. So to take a little detour, just to show you, if you have not seen this before, This is basically it's a visualization of the Bitcoin network. What is happening over here is new transactions are coming in, right? On the left side, everyone can see that. And every once in a while, those transactions are getting validated. So these are new transactions. This new block was found about 3 minutes ago. There are about 1,000 transactions being validated by it. And they keep occurring on an average of 10 minutes. That's the amount of time it takes for a block to a transaction to get confirmed on the Bitcoin network. This is not completely accurate, but let's go with it for a bit. All right, so blocks basically validate transactions. They do that through proof of work. It says every minute away. That's roughly about every 10 minutes. It's a Poisson distribution, so it can be as little as a few seconds as well. A new block confirms the transactions in it, and every single block that has come before it. So it forms a chain of blocks going all the way to the first block that Satoshi himself mined, right? Yeah. So what is the blockchain? It's a chain of blocks. There are some really cool things you can look at if you want to understand what this problem of double spending was before Bitcoin and how people were solving it. It's called, you can write this down, it's called the Byzantine generals problem. Okay. I would highly encourage you to go study it, because it will make you appreciate Bitcoin more than the average Joe. The Byzantine generals problem. Okay. And this diagram will make sense once you look at that. Yes?
How long does it take for the block to confirm like 1,000 transactions?
The question is, how long does it take for a block to confirm 1,000 transactions? The confirmation time, the time that you spend validating transactions, it does not depend on the number of transactions. Yeah. We're going to talk about that at a later point. Yes?
Is everybody who's validating working on the same block at the same time?
So the question is everyone that is trying to find a new block looking at exactly the same block? No. The block, you can pick and choose the transactions you want to validate. The amount of transactions in there, the type of transactions in there, the data in those transactions is completely irrelevant when you try to find a block. It doesn't determine the difficulty of that block. We're going to talk about that later. It's just a little advanced right now, until the next session. Yes.
So this blockchain, can it be seen like a linked list, and you could go back, I mean, from the beginning of time since the blocks were?
The question is, can the blockchain be seen as a linked list and you can go to the beginning of Bitcoin time? Yes, that's exactly how it's stored on the network. So that is the blockchain, right? When a new transaction comes in to the network and it has not been put into a block or confirmed yet, it is not actually part of the blockchain. It's waiting to become a part of the blockchain. Everything that is in the blockchain is a chain of blocks, okay? And every block is a bucket of transactions. Okay. Yes?
Also, just to be clear, nothing on the blockchain is private, and privacy exists outside.
So the comment is, nothing on the blockchain is private. Yes, you can see everything that goes on the blockchain, right? So in order to get your privacy, you have to put a representation of your data on the blockchain, not the actual data itself. We're going to talk about that in a bit. Thanks. Okay. Right. We shall move forward then. So who are the actors in the blockchain? Actors being a pretty loose term here. So there are users like you and I. We push transactions into the network, right? You need us. There are nodes in the network. These nodes are responsible for keeping up-to-date copies of the blockchain. So when you find a block, you update the blockchain. They're trying to keep that up to date. Right? And there are some rules they're trying to follow to make sure the new block is not an invalid block and someone is not trying to dupe them. And they're coming, they are individually verifying that blocks are valid, and if 51% or more of them agree that a given block is valid, then that block is valid for the entire network. It's called the consensus of the 51% nodes on the network. As a side, if more than 51% of the nodes on a network are dishonest, they will agree on a batch of transactions that should not be agreed upon. So that is when a network becomes insecure. But that's a little advanced. The third actors are miners. These are the people that, or nodes that validate the new transactions. These are the people that have set up a few stadiums worth of ASIC farms. They're trying to churn out computations. You might have heard about them in the news. What they're trying to do is, with all those computers, they're trying to find the next block so they can get the reward from the blockchain. Whenever you find a new block in Bitcoin right now, the reward is 25 Bitcoin you get every single time you solve that block. And you also get the transaction fees that you and I pay when we transact on the network. Right, so they're not doing it for charity. These are the people securing the network. You need them. So in the end, the Bitcoin network looks like this. There are users, you and I. We have our public key, private key, Bitcoin address. We're going to talk about that in a bit. And then there's the network. It's a lot of nodes talking to each other. And they're trying to keep the blockchain up to date. And there are miners, they're listening for new transactions. As soon as they come in, they put them in a block because they want to extract the fees from those transactions, and they try to find a new block. Okay? Yes?
Do they actually validate the transaction before they? Because I'm pretty sure their motivation is to try to get money, so they try to use all their resources trying to come up with a new block instead of trying to validate, right? Or am I wrong?
Yes. So the question is, do these miners validate the transaction or just put them in a block? Because it will be more optimal for them to put it in a block and just try to find a new block that satisfies the conditions put out by the network. Yes, most definitely. This is something they do, but when you find a new block and you've included an invalid transaction in it, all the rest of the networks, at least 51% of them, won't agree that this is a valid block. So all that work you did goes to waste. So I could push in bad transactions into the network, and I know you're picking them up. I can block you from gaining any rewards from the system if you don't validate the transactions yourself. Right? Yes?
Is the transaction being validated by multiple miners?
Sorry?
Is one particular transaction, can it happen where a transaction is being validated by multiple miners?
The question is, can the situation occur where one transaction is being validated by multiple miners? It is always the case. Yeah, it is always the case. So what this leads us to is you've got a lot of people trying to find the new block. What if two of them find a new block at the same time? Right? What happens then? At this point, you wait for another block to be found, and another block to be found, and another block to be found. Every single time you find a new block, you are pointing to a block before it. Okay, so you can only point to one or two of one of those 2 or 3 or 4 blocks. Okay, so when you keep finding new blocks, the longest chain wins. Does that make sense? Right. Let me show you over here. over here, 2 blocks were found at the same time. Okay? Now you don't know which one is valid, so you wait for the next one. Okay? You wait for this one. This line actually shouldn't exist. This line shouldn't exist. So you waited for the next one. The next one was pointing to this chain, not that chain. Right? The longest chain wins. Okay? There are a lot more nuances to this. We're going to talk about that in a bit. Okay? Alright. Alright, let's talk about cryptographic hash functions before we take a break. How many of you have Node.js installed on your, okay, good. For those of you who do not have Node.js installed, we're going to install that in the break, which is coming up in 10 minutes. Alright, so what are cryptographic hash functions? One of the easiest ways for me to understand it was through this little problem. Consider a girl, Alice. She is super competitive and she's trying to solve a math problem. Okay. She spent some time solving this problem and she is really excited that she got the solution. So she's bragging about it to Bob. And Bob is like, if Alice can do it, I can do it. He's competitive too. But how does he know he came up with the answer Alice did? If Alice shares the answer with Bob, Bob can easily lie that he got the same answer. If Bob shares it with Alice, Alice can easily lie. So how do you make sure that both of them got the same answer without actually sharing that answer? You can do that through cryptographic hash functions. Right? What is a cryptographic hash function? It's a one-way function. It's hopefully a one-way function where you put in you give it some input of arbitrary length, and it comes out with a fixed output that you can look at. It looks random to you, and you can't go back from the output to the input. So, for example, the string fox over here, you put it through this one-way function, and you came out with an output of the cryptographic hash function, which is called the digest. The digest is basically a very large integer. You represent it as a hexadecimal string over here. You can look at this string, but you can't determine whether fox was actually this string unless you brute force all the different possible strings out there and then come out with, fox. And that's really hard for you to do. So one of the core properties of cryptographic hash functions, it has to be one way. It has to be nearly impossible, if not impossible, to go back from the output to the input, to go back from the digest to fox. Okay, so Alice and Bob can create calculate the hash function of their answer, calculate the digest of their answer, and they can share that digest with each other. No one will know the answer. Right? Only the person with the correct answer will come up with the same digest. That's a cryptographic hash function. If you modify anything in the input, you will get a completely different answer to the cryptographic hash function. Okay?
That's actually really important. It's like very different. A single bit change results in a very different.
Yeah, the comment is that is super important. Yes, if you change anything in the input, the output is going to be completely different. And if it is not, if you are able to come up with two inputs that give you the same answer, that is called a collision. About 15 or 16 years ago, we used to do MD5 checksums of different files, and we used to have cryptographic hash functions that were similarly low strength, like 64-bit outputs, we started finding collisions where we could find two different sentences that hashed to the same thing. So we were like, okay, this is not good. Let's come up with something new. We came up with SHA-1. And we were like, yeah, SHA-1, there might be some collisions in there. Okay, let's come up with something new. SHA-2. And SHA-2 is what Bitcoin uses today. SHA-256. So the answer in Bitcoin is, it's a 256-bit answer. In MD5, it was 64-bit answer. And SHA-128, it's a 128-bit answer. The longer the answer, the lower the chances of the collision, in general. But different implementations differ.
Does that mean that if somebody can reverse SHA-2 and go the other direction, that Bitcoin, the network will then collapse because people can reverse?
So the comment is, so does that mean if someone can come up with a way to reverse the one-way function and come up with the input from the output, take the digest and come up with the input, yes, Bitcoin will break. A lot of other things will break. I'm sure in an alternate universe that has occurred. So what do you use these checksums for? You can use them for message integrity. You can use them to, just like Alice and Bob, you can use them to verify answers. So we can look at examples of the SHA-256 hash function in use by looking at this little link. After the break, we're going to actually do this in Node.js ourselves. Not code the function ourselves, but actually use it. So you can come up with some data in there. You can calculate the hash function. So that's a hash function. The last four characters are 1625. Let's change one thing in there. I'm just going to type a 1 in here. Right. Calculate a new hash, completely different answer. Right. Yeah, that's all I wanted to say about cryptographic hash functions. They're used in transactions and blocks as well. We're going to talk about that later. What do you use these hash functions for? You can detect duplicate data on your disk drive, so you can calculate hash function, for example, MD5 checksums, call them checksums of all your files, and if any two files come up with the same checksum, they are duplicates, right? You can use it in fingerprinting for your digital files, or you can just use them as hash values that you can feed into your random number generator, use it as a seed. Yeah, it's really up to you. This is a great tool to geek out on. Yeah, I think we'll pause at this point. Any last questions before we go eat donuts? No. Okay. Good. See you.